Alright, so now we're going to go over coordinate geometry. And this will be very much related to what we've been doing before with functions and coordinates, x and y points. And I've even mentioned this before. So let's just jump straight in. How do we represent points on a coordinate system? Points are numbers that are in a pair. So this would be a point, 3, 4. 5, 6 would be a point. Negative 10, 0 would be a point. But how do we represent this graphically? Well, we would use a coordinate system, a rectangular coordinate system, where we draw two perpendicular lines, where perpendicular means they meet at right angles, okay? So this is a right angle, right angle, right angle, right angle, which is 90 degrees. Okay, so this horizontal axis would be the x-axis, and this vertical axis would be the y-axis. Now, all it is just a sequence of points. We talked about the number line, the real number line. That's what the x-axis is, and the y-axis is the same, except they are perpendicular to each other, and even though they have the same points, they both are needed to make up a point, a coordinate point. So the point on the x-axis will be all of these points, and the same for the y-axis. However, you need them both to define an actual point on the grid. So you need 2 points to define a point on the grid. Alright, so let's find 2 points, one on the x-axis and one on the y-axis, and we'll see how it makes this coordinate. Okay, so how about this? We'll make that 1, 2, 3, 4, 5, and this will make negative 1, negative 2, negative 3. We'll make this negative 1, negative 2, negative 3, and this 1, 2, 3. Okay, so what did I do here? Well, as you can see, some part of the y-axis has positive points and some have negative points, and the same for the x-axis. Now, this is why that's so. So if we cut up the coordinate axis into these 4 quadrants, 1, 2, 3, 4, and it has to be in that order, we see that this is the positive x-axis, positive y-axis, so that means any point in this section will be positive x, positive y, so x and y will both be positive, and then for the second coordinate, the second region, we're going to have a negative x and a positive y. So we're going to have numbers like negative 2, 3. So the x points are negative, all of them over here, but the y points are positive. And for quadrant 3, our x's and y's would be negative x and negative y. So we'll have something like negative 2, negative 3. And for the fourth quadrant, we have positive x and negative y. So something like 3 and negative 4. So one way of looking at it is, if we go vertically up, that's the plus y direction. If we go to the right, it's the plus x direction, which only makes the opposite directions negative. So down would be negative y, and left would be negative x. So if I were to find the point 2, 3, then I would go to the x-axis first, because our points are x, y always. So I would go find 2 here. 2 is right here, and then I would go up 3. And so that point is 2, 3. In other words, the x value is 2, which is that point, and the y value is 3, which is this point. So we draw the point at 2, 3. Go across 2 and up 3. Now what if I wanted to find the point 3, negative 5? Then I would find the x value that is 3, which is here, and then I would go down negative 5. And so that would be somewhere here. This would be 3, negative 5. Okay, great. So that's how we label points on an axis. So let's try some more problems concerning that. Okay, so here I have my positive x-axis, positive y-axis. And here is the origin, or the point 0, 0. Now I want to graph these points. The point P is 0, 1. The point Q is 0, 2. The point Z is 2, 0. And the point F is 1, 0. Okay, let's graph point P. Point P is 0, 1. So where is 0 on the x-axis? It is here. Now, where is 1 on the x-axis? Well, we just go up 1 and then we'll be here. So 0 and then up 1. So our point is here. This would be P, which is 0, comma 1. Now let's find Q. 0, comma 2. Well, we're here at 0 and then we go up 2. So that would be around here. So Q would be 0, comma 2. Now let's find Z, which is 2, comma 0. So we need to move over to the right 2. And so here's 2. And then we need to go up 0. So we're right here. We're where we need to be. We are already here. So 2, comma 0. And now let's do F, which is 1, comma 0, which is 1. 1 would be here, halfway between 0 and 2. And then go up 0. So that's it. So F is 1, comma 0. Now these are our points. And I'm just eyeballing where 2 is and where 1 is, and that's fine. So let me highlight our points. So we have 1 here. We have 1 here. 1 here. 1 here. And 1 here. Great. So these are our points. Now, what can we see about these points? Can we find what the distance is between any two of these points? We know how to graph them, but what if I want to find the distance between the 2 points? Let's find the distance between, how about Q and P? P is 0, comma 1, Q is 0, comma 2. Well, obviously, we are looking for this distance here between Q and P. Well, P and Q both have an x coordinate or an x point of 0, but it goes up 1 from P to Q. So this distance here is just 1. So the distance between P and Q is 1 because we only went up 1. It's a vertical distance. So we can represent the distance PQ as this. So we have PQ, this line segment, the distance of that would be 1. Okay, I'm just going to write 1 unit. And so now we know it's 1 because we just went up 1. Now what about the distance between F and Z? Between F and Z? Well, again, we just went across 1 unit. We went to the right 1 unit, so FZ distance is also 1 unit. Now, how can we find these distances without looking at the graph? Well, let's see what PQ is in terms of its points. So P is 0, 1 and Q is 0, 2. So we have 0, 1 and 0, 2. Well, this is the x value, this is the y value, and likewise here. Now, I have x's and y's on both places, but let me label the x's and y's. I'm going to call this x1, y1, and x2, y2. They're both x and y points, but I just want to label them so that I don't get confused between the x points and the y points. So the way to actually find the distance without counting it on the graph is to use the distance formula. And let's see if we can use this formula to get PQ as 1 unit. So the distance formula. That distance formula is equal to, D for distance is equal to the square root of y2 minus y1 plus x2 minus x1, but then you square each quantity, okay? So the square root of y2 minus y1 squared plus x2 minus x1 squared. So if we have 2 points, and I'll write you need 2 points. If you have 2 points, you plug it into this D, this distance formula, and you get the distance between the two. So let's use our 2 points. We have 0, 1 and 0, 2. So 0, 1, x1 is 0 and y1 is 1, x2 is 0, y2 is 2. So D equals the square root of y2 minus y1, which is 2 minus 1 squared plus 0 minus 0 squared. And then we would get the square root of just 1 squared. Alright, because this cancels out. And that would just equal 1. So yes, we did get a 1 unit, a distance of 1 unit. And notice that the x values, the x distance, or the horizontal distance was 0. Doesn't that make sense? Between P and Q, we don't move any horizontal distance. We just move up, which is why the only non-zero quantity here would be 2 minus 1, or the y parts of it, or the vertical parts, y2 minus y1. Now, let's see if we get the same thing for fz. The f point is, let's see what the f point was. The f point is 1, 0, and the z point is 2, 0. So let's do that here. We have 1, 0 and 2, 0. So let's find the distance between the 2 points. Well, this is x1, y1, and x2, y2. That does not change. Okay, so d equals the square root of y2 minus y1. So that's 0 minus 0. And see, the y parts are 0 now. Plus, what is 2 minus 1, or x2 minus x1? Okay, and then you square it. So that equals the square root of 1 squared, which is, again, 1 unit. So we got the units. We got the distance as 1 unit and 1 unit. Great, but that's not that interesting, okay? I want to find the distance now between points that are not vertical or horizontal, that are diagonals, or that are at an angle that is not purely horizontal or vertical. So let's try and find the distance between Q and Z. How does that sound? This distance here. All right, so let's try and find that. And I'll draw that distance right now. That's that distance. And we can tell it's going to be larger than 1 unit. It just looks bigger. So let's find it. Q is 0, 2, and Z is 2, 0. So those are our 2 points, okay? So we have Q as 0, 2, and Z as 2, 0. So here's x1, y1, x2, y2, and the distance is the square root of y2 minus y1, so that's 0 minus 2. What's 0 minus 2? It's negative 2. Squared plus x2 minus x1, which is 2 minus 0, which is 2 squared. So let's simplify. We get the square root of, well, negative 2 squared is 4, plus 2 squared is 4. And so we get that it equals the square root of 8. Well, we can simplify the square root of 8 by just finding what perfect square is a factor. Well, that's the square root of 4 times the square root of 2, and that equals 2 radical 2. So the distance QZ is 2 radical 2 units, and 2 radical 2 is bigger than 1. So notice how we just found this black distance here by not counting, because it would be really hard to count. We use the actual distance formula. And likewise, we can find the distance between P and F. Okay, so 0, 1, and 1, 0. Now we know that's going to be less than the distance QZ, but let's find it anyway. So P and F. So P and F, that would be, let me just write it like this. So we have P as the point 0, 1, and F as the point 1, 0. And so let's label our x1s and y1s. So we have x1, y1, x2, and y2. And so our distance would be equal to the square root of y2 minus y1, or 0 minus 1, which is negative 1 squared, and plus x2 minus x1 squared, which is 1 minus 0 squared. And that equals the square root of, well, negative 1 squared is 1, plus 1 minus 0 squared is 1, and that equals the square root of 2. So the distance PF is the square root of 2. And really all you're doing is plugging into this distance formula, which you should write down and memorize. So I'll box that again. That is right over here. So here we go. This is the distance formula. All right, so don't forget that. Okay, great. So we have all the distances. Now let me write the distances out just so we can see them in one page. We have let's see, PQ as equal to 1. We have FZ equal to 1, and we have QZ equal to 2 radical 2, and we have PF equals to radical 2. Now, did we miss any combination? Is there any other combination here of lines that we could have used? Yes, of course. We could have used, how about QF? We could have used this, or we could have used PZ like that. But it's okay, because we have the gist of it now. We know how to find distances between 2 points. Now, I want to show you how to find the distance another way, without using the distance formula, without using it directly, okay? We can actually derive the distance formula. So let's try that right now. It's pretty interesting. So what if we have the same coordinate axes, or rectangular coordinate system, or grid, where we have x comma y, and now we have these 2 points. So we have one here called P and one here called Q. I'll make P equal to 1 comma 1 and Q equal to 3 comma 3. So you can make these up as long as it makes sense. For example, you're not going to put a negative number here. For example, this point cannot be negative 3, 3, because negative 3 will be on this axis. Okay, so now we have these 2 points, and of course I'm asking you to find the distance between the two. But pretend you don't know the distance formula. All you know is the Pythagorean Theorem, which you should know by now, but I'll go over it. So all it says is, I'll do that as an aside, if you have a right triangle, like this, a right triangle, which means this angle is 90 degrees, then you can find a relationship between this side, which has a distance of A, this side, which has a distance of B, and this side, which has a distance of C. And now these lengths are all related, but let me just label it. This B is a length that is called the leg, and this is also a leg, but this C, which is the longest length, of course, is called the hypotenuse. Hypotenuse. Okay, and this distance called the hypotenuse is opposite the 90-degree angle. And now, what is the relationship I promised? It is that a squared plus b squared equals c squared. So if you have any right triangle, this follows. For example, if we have a right triangle with the side lengths of 3 and 4, that means that 3 squared plus 4 squared equals c squared, and this is c. So let's solve for c. What's 3 squared plus 4 squared? That is 9 plus 16 equals c squared. 9 plus 16 is 25 equals c squared. If c squared is 25, then we know c is 5. So that means this length equals 5. And yes, this length of 5 is bigger than both of the legs. Great, so now that we know the Pythagorean Theorem, which I'll label here, Pythagorean Theorem, and this is something you should memorize, we can now use that to find distances in our rectangular grid. So I have these 2 points, Q and P, and I want to find the distance PQ or QP. The way to do that is to break it apart into a vertical and horizontal distance. So this will be the vertical distance, and this will be the horizontal distance. But both of these distances make up PQ. So I'll call this point L. And so this is PL, and this is LQ. And now to find this, this horizontal distance, all we need to know is what this point L is. And what is that point L? Well, if this point here is 3, 3, that means that this is an x-coordinate of 3. So we know that that's an x-coordinate of 3. But what's the y-coordinate? Well, we know that this point here is 1, 1, which means that this is a y-coordinate of 1, which means that over here is a y-coordinate of 1. It's right across from it. It doesn't go down, okay? It just goes straight across. It's a purely horizontal line. Now we can just say that it's 3, 1, all right? It goes up 1, and across 3, or we can just think of it as across 3 and up 1, okay? And so the point is 3, 1. Now that we have all 3 points, let's actually find the distances. We're not using the formula. All we're using is common sense. If this is 1, 1 and this is 3, 1, how much time or how far is P from L? Well, it goes up just 2. Because we start at 1 and then we go to an x value of 3, so we move 2 spaces, so this is 2 units. Or you can think of it as 3 minus 1, so this is a distance of 2 units. So I'll write that this has a distance of 2 units. Now what is this distance here? Well, we start at 1 and then we go up to 3, so that's also 3 minus 1, which is a distance of 2 units. Now that we know this is basically a triangle, a right triangle with a distance of 2 here, distance of 2 here, and we're looking for PQ, well, let's use the Pythagorean Theorem. So we have 2 squared plus 2 squared equals PQ squared. And I'll call PQ just PQ. We can leave it like that. It's a quantity. So PQ squared. What's 2 squared plus 2 squared? That's 8. Okay, and that equals PQ squared. And so we would take the square root of both sides, and we get that PQ is a square root of 8, or 2 radical 2. All right, so great. We learned 2 ways to find the distances between points. And what are those 2 ways? We have the distance formula. If we use the distance formula for the previous problem, we would still get 2 radical 2. And the Pythagorean Theorem. And then we can think of a whole bunch of different problems with these 2 methods to find distances between points. There are so many different fields that use this concept. And so let me give you another problem that uses both of these concepts. So let me go and find where I had that problem. And so that is going to be somewhere across. Yep, right here. Great. So we have points here. This point is the school. Imagine you're living somewhere and there's a school, and then you walk some distance, and then there's your house, and then you walk some distance, and then there's your workplace, and then you can go all the way to school. My question to you is, if you start at school, how far do you have to walk from school to home to work, back to school? In other words, if you're at school, how far do you have to walk to get back to school by covering every single location? So if you do that problem, all it's saying is find the lengths between all the 2 points and then add them up. So find the distance between school and home, then home to work, and then work to school, and add them up. So let's use the distance formula. Why? Because we're not so entirely sure that this is a 90-degree angle. If it's not, then we cannot use the Pythagorean theorem, so we have to use the distance formula. So first thing we do is label the points. This would be x1, y1. This would be x2, y2. And this we can make x3, y3. Great. So which one should we do first? Let's do school to home. So school to home. How far do you have to walk to go from school to home? Well, we would use the distance formula. So d equals, and I'll write the distance formula here for reference since we're learning it for the first time. So y2 minus y1 squared plus x2 minus x1 squared. So that would be x2 minus x1 squared. And all of that's under the radical sign. Okay, so what is that distance? That would be 5 minus 7, y2 minus y1. 5 minus 7 is negative 2. We square that. Plus x2 minus x1, which is 3 minus negative 4. 3 minus negative 4 is 7. So that's 7 squared. And that equals the square root of 4 plus 7, or 11. So the distance here is square root of 11. Now what about the distance of home to work? Home to work. All right, so then that would be these 2 points here. So we have d equals the square root of, in this case, y3 minus y2. And it doesn't matter which order you do it in. You could do negative 3 minus 5 or 5 minus negative 3. So y3 minus y1 would be negative 3 minus 5, or negative 8 squared. Plus, what is now x3 minus x1, which is 3 minus 3, or 0, and then you square it. And so that will give you a distance of the square root of 64, which is 8. So this is a distance of 8 from home to work. So let's start labeling what we have. We have this distance as square root of 11, and we'll call this feet. And then this has a distance of 8 feet. And now let's find the distance between school and work. So I'll do that here. School and work, or school to work, which is the same as work to school. And what are the 2 points? Well, we have school as negative 4, 7, so I'll write that here since we can't see it, and work as 3, negative 3. So 3, negative 3. Okay, now we use the distance formula. So we take the y components and subtract them, so that's negative 3 minus 7, which is negative 10, and square that, plus then 3 minus negative 4, which is 7, and square that. And so we get the square root of 100 plus 49. And so the answer is the square root of 149. All right, so now we have all 3 distances. So let's write that, the square root of 149. And so since we have all 3 distances, we just need to add them. So the total distance is, and we don't have to find the simplified version, but the total distance is d, alright, d total equals 8, see, 8 plus the square root of 11 plus the square root of 149. And so that's how far you need to work to go all the way around to come back to school. From school to go back to school, you need to walk that distance. Okay, wonderful. Now I want to try one more problem that we can make up. Okay, so we have the coordinate system again. And this time, I'm not going to draw just one line. I'm going to actually draw a shape. So we have let's see, we have this line up here, this line across, and this point is A, this point is B, and this point is C. Now I want us to find the area of this rectangle, okay? And we know that this is the origin, of course, and I'm going to tell you that this A point here is 2, 1, all right? And we need to find the area. Is this possible? It seems like we don't have enough information, but this is all we're given. So let's think. How can we find the area of any rectangle? Well, we just multiply the length by the width. So the length times the width gives us the area of a rectangle. So I'll write that up here if you didn't know. Area of a rectangle, and that's a rectangle on the bottom, is equal to length times width, or L times W. Awesome. So how can we find L and how can we find W? Well, I don't know what this point is or this point, but I know these 2 points. So using these 2 points, I'm thinking I can draw a diagonal here, and I know that distance if I use the distance formula, and then I can find this length and this length. Or I can draw a line here and just use the Pythagorean Theorem. So let's do the latter. So let me draw the line here. Okay, great. And now if this is 0, 0 and this is 2, 1, what does that make this distance? That distance is just 2 because we went over 2 to get an x-coordinate of 2. And now we know that this distance must be 1 because we go up 1 to get to A from B. So now we know that this point here for B would be 1, 0. And this point C now, what is that? Well, here we're at 0, 0, and then we go up 2. So that would be 0, 2. Great, so we have all 3 points actually. We have A as 2, 1. We have B as 1, 0. And we have C as 0, 2. And of course the origin is 0, 0. Now, our original idea was to find the area. So can we find the length? No, the length must be the line segment that is CA. Well, CA, we can use the distance formula or just use logic. If this is 0, 2 and this is 2, 1, that means to go from C to A, we must travel a certain horizontal distance. And that horizontal distance is the 2 minus the 0, okay? So that means that this is where we start and this is where we end. We take the x components and subtract them. So the final x value minus the final y value, the final x value minus the initial x value, sorry. So that would be 2 minus 0, which is 2 units. Okay, and then the width would be the final y value minus the initial y value. So this is the final y value and this is the initial y value if you jumped from here to here. Okay, and that would be 0 minus 1. But distances can never be negative, so instead of -1, we'll just make it a 1. So AB equals 1. And yes, you can do that because all we're looking for is a distance, not an actual negative or positive value. We're just looking for a distance. Now, we have the length and width, so getting the area is just a matter of multiplying it. So area equals L times W, or length times width. So the answer is 2 times 1, which is 2 units squared. Area is in units squared. So that is our answer. The area is 2. That's pretty interesting. And since this diagonal cuts the rectangle in half, this is 1 unit squared, and this is 1 unit squared. And we can even figure that out because this distance is 2, this distance is 1, so this is a triangle. Area of a triangle is 1/2 base times height. So that's just, I'll write this as an aside. Area of a triangle is 1/2 base times height. and the base is this horizontal distance, the height is this vertical, so that's 1/2 1 times 2, or 2 times 1, okay? And 1/2 2 times 1 is just 1, which is interesting and makes sense because this is 1 unit, and do the same logic here, and this is 1 unit, and so it makes an area of 2 units squared. So actually this is 1 unit squared and this is 1 unit squared. Don't forget the squared, or else it's just a distance, not an area. Alright, so in the next video we'll do some more problems regarding this topic. Alright, so let's do some problems involving coordinate geometry. Here, for number 1, we have a rectangular grid system, or coordinate system, with the quadrants 1, 2, 3, and 4 in Roman numerals. A is asking which quadrant is the point 3, -100 in. B is asking which quadrant is 4, 5 in. So pause the video and we'll go over it. Alright, great. So let's go over part A that you did. So 3, -100. So 3 is a positive x value, so it'll be around here. -100 is a negative y value, so it would be somewhere down here, which means it would be in the 4th quadrant. So the answer is 4th quadrant. B, which quadrant is 4, 5 in? 4 would be on the positive x-axis, and 5 would be on the positive y-axis. So somewhere here, or the 1st quadrant. Great, now let's look at number 2. Here we have a coordinate grid system with a point D, and the D is 3, 1, okay? So it's asking to complete a square with the points A, B, C, and D. Okay, so you have a coordinate system, and I want you to make a square with the points A, B, C, and D, like this. So this would be A, B, C, and D, for example, and then find the points A, B, and C, since you already have D. So basically, make a square on this grid, and then find all of the 4 corner points. So pause the video and take a moment to try that problem, and then come back. Alright, so let's go over number 2. So if we have D as 3, 1, and then we know that that from D to this x-axis would be 1. So if this is 1, and then this must be 1 because it's a square. Okay, so if that's 1 plus 1, this whole distance is 2. So that we know the side length of the square is 2. So all the other side lengths must be 2. So I'm going to extend this point over here until some other point, and the point that we'll find. I'll call this point C and this point B. So we already know what C is. That would be 3. 3 is this point here, -1. So we can go down 1. So that would be 3, -1. And now we need this distance to be 2 as well. If this point is 3 on the x-axis, we can move over 2, and this would be 1, -1. And so then A would be up here. Alright, so I realize this does not look like a square. The reason is because I drew this length way longer than this length, but all that matters are the points, okay? So if we have the points correctly, if you write them correctly, then it should have side lengths that are equal, therefore it's a square. So that A point would be, well, you're on the 1 x-coordinate, and so we need to go up. But how many points? Well, from here to here is 1, and we know this whole length is 2, so we need to go up 1 point. So this is 1, 1. Great, and so we made the square. I'll write it over again so it looks neater. So we have this coordinate axis and x and y. Don't forget to draw the arrows, meaning it goes on forever. And here we have 1, 1 for A, and then for C we have 1, -1 for C, and then or rather this is B, and then for C we have 3, -1, and then for D we have 3, 1, and now this looks more like a square. And so all the side lengths are 2, and the area is 4 if you wanted to do that, 4 units squared.
Thank you for watching this video.